and welcome to Geeks for Geeks. Today, we would be discussing the problem named as maximum. So, in this problem, you are given an array and you need to find the maximum and the minimum of all the elements in an array. Then you need to sum it and then you need to return it. So, here you can see that the minimum number is -4. So, I can say that the minimum number is -4 and the maximum number is 5. So I can say that the maximum number is equals to 5. And when they are summed up, you can see that the answer is 1. That is why the output to this is 1. The very first approach you can think of is that I would simply iterate over the array and then I would find the maximum and the minimum. This is what you can do. But this is not the very first approach you should move forward with if you are in an interview. Why? Because this has a less time complexity. So you need to start with a greater time complexity. So you can simply see that what I would do is I would simply sort the array and then the first number would be minimum and the last number would be maximum. Okay. So now you need to move forward in a way that see the objective is to find the smallest number and the largest number. So we shouldn't be concerned about all the other numbers. So what we can do is we can simply iterate by using for loop, okay? And we can have the maximum and the minimum element. So how we can have it? So what I would say is I would say minimum is equals to -2 and maximum is also equals to -2 when I'm on the first element. Then I would start from the next element. So when I have 1, so I would say if 1 is less than minimum, I would assign it, but it is not. So I won't update it. But 1 is greater than maximum, so I would update it with 1. Then I would move forward to the third index, and then I would say -4. It is less than min, so we would update it, -4. And the maximum number is still 1, okay? Because we didn't receive any number greater than 1. Then we have 5. 5 is not less than min, so we won't update it. Max, yes, it is. So we would update it to 5 itself. Okay. Then we would come to the last index and we would say 3. 3 is less than min. No, it is not the case. Max, no, it is not the case. At the end, the min and max would have the numbers, and you can say that yes, the sum of both is the value itself. So what is the time complexity of this approach? The very first approach of this is n log n. Okay, if you're using a merge sort or a quick sort. Okay, and if the numbers are less, you would be using a counting sort, which has a time complexity of big of n. And then returning the minimum and maximum is a constant. Okay, so n log n plus 1. And then this is big of n if we talk about the number of comparisons. So what I would do is I would quickly code it. Okay, so let's go to the coding part and we would see how it is. Okay, the coding part is an easy one. What we would do is we would have for int I is equals to 1, I is less than n, and I plus plus. And then I would say that I would initialize the int mx, which would store the maximum as a of 0, and mn is equals to again a of 0. Okay. Now it's simply very easy that if the particular number is greater than max, we would update the max to a of I. And if the particular number is less than mn, then mn is equals to a of I. Okay. At the end, you would be having the max and min, so you would just return mx plus mn. Fair enough? So now it is greater and it is larger. So now we would compile and run. Yes, it is getting a correct output for the sample test case. Now let us try to submit this. And yes, we get an AC. But let's talk about the time complexity, but in the form of comparison. What is the number of comparison? Time complexity remains big O of n, but the number of comparison is the thing that we need to talk about. See, basically, this is an assignment. So this is constant. So I won't be writing this. I would be writing comparison. So for each element, we are doing one comparison as well as one more comparison. So I can say that in total, I have 2 into n minus 1 comparison. Okay. So can we narrow this down? Can we reduce the number of comparison that we are doing? Okay. So now the intuition to move forward is to think in a scenario that if you observe that not every time this max and min both would update. Either this would update or either this would update. I would just tell you what I'm trying to say. Suppose we have my mx is equals to positive 5 and mn is equals to negative 5. So if we see a number 6, then we know that this would update, which is greater than max. If we see a number less than, less than min, then this would update not this. So this is the very first intuition that at both of the times this shouldn't update. So now you can narrow it down and you can have it. But moving forward to that, what you can think of is that I don't really need to do two comparison at all times. Okay, I can reduce. How I can reduce? I can work in terms of groups. Okay, to be specific, I can work in terms of pairs. What do I mean by this? I meant this that what I can do is, suppose this are pairs. Okay, and this is the order one. So what we would do is, instead of this, we would say this, and we would handle it explicitly. Okay, so what I can do is, I would have mx is equals to -2 and mn is equals to -2. Let's write the mix and match. So minimum is equals to -2 and maximum is equals to again -2. Now let's come to this scenario. And we told that we would work in terms of pairs. So this as one index and this as one index. So let's see. So if we have this as greater, okay, this side is greater. Which one? This side is greater and this side is smaller. So I can say this is greater and this side is smaller. So now let's try to think. So this greater thing would affect the maximum number and the smaller thing would affect the minimum number. True or not? Yes, it is. Same thing would happen for here also. Here, the greater is this and the smaller is this. So now I can say that again, this greater would affect this and smaller would affect this. Now there is one more thing that allows us. If we know the greater and the smaller, then we don't need to do the comparison for both the elements. Like we know that this side a smaller element is being kept, this side a larger element is being kept. Okay. So the algorithm would be such that we know the min and max at this point. So let's see this. Okay. This is the index 0, this is index 1, this is index 2, this is index 3, and this is index 4. So what we would do is we would come at this index I is equals to 1. So when I is equals to 1, and there are two scenarios. Either the first element would be small, either the second element would be small. Okay. So let's take the first scenario. Okay, let me write it in red. The first scenario is right is small. That means this is small. So when this is small, that means that a of I is greater than a of I plus 1. True. Next we go down and we can say that this max thing would only happen with this. Max thing would affect this and min thing would be affected by this. So I can say that if a of I, this is maximum. If a of I is greater than max, update it. And next we do one more comparison, that if a of I plus 1, a of I plus 1 is less than min, then we would update it. So if you observe that we are doing 3 comparison in total. One is this and one is these two. Because we know that suppose we are in a group. Okay, suppose मुझे छोटा लड़का चाहिए और मुझे पहले से पता है दो लड़के में कौन सा छोटा है. So मैं उसी पे फोकस करूंगा, दो लड़के में जो छोटा है. दो लड़के में जो बड़ा है उससे मैं फोकस करूंगा ही नहीं ना. Fair enough? Same thing we would do here also. Okay, but it seems that we are doing more, but in reality we are doing less. Why? Because we are working in terms of pairs. Okay, so we can say that n by 2 multiplied by 3, roughly we would do a detailed comparison, but we can say that n by 2 divided by pairs multiplied by 3. We can do that. Which is less? Yes. Now let's see. Okay. So, and the exception is also 100. So if the number are odd, then n by 2 plus 3 plus 1. Okay. Added 1. One step would be added. Okay. Else we would move forward with that. Now the coding part is very easy. Let us move to the coding part and we would be able to code it. So we would do the same thing, that mx is equals to a of 0 and mn is equals to again a of 0 itself. Okay. And then we would initialize I is equals to 0. That we are first considering that the number of elements are even. That is 1, 3, 2, 5. Suppose we are considering this and I is pointing to this. Okay. Fair enough. But let's suppose the scenario. So let's move forward with this scenario. Let's first consider that we have only even elements. So now what I can say is while I is less than n minus 1. And we would do the same thing, that if a of I is less than a of I plus 1. So this means that out of this pair, okay, out of this pair, this one is our minimum and this one is our maximum. Okay, we would go down and we would say that if the minimum number is affecting the minimum wala minimum ko affect kar raha, that means if a of I is less than minimum, we would update minimum is equals to a of I. Okay, and then we would ask that if maximum is affecting the maximum or not. If a of I is affecting the maximum point, then mx is equals to a of I. Minimum is affecting the minimum, maximum is affecting the minimum. Let's take the second scenario where a of I is greater than a of I plus 1. Here, this time, a of I is greater. So the conditions here would be the opposite of conditions at here. I can say that if a of I is greater than mx, that means maximum is affecting the maximum. Same way. Okay. So I can say that mx is equals to a of I. Next, if a of I is less than minimum, a of I plus 1, because a of I plus 1 is the minimum one. So I can say that minimum is equals to a of I plus 1. We are done. Now, if the number of elements are even, we can do it. So then we would simply return mx plus mn. But suppose the number of elements are not even. So in this scenario is absolutely very easy to consider, as we have seen. Suppose this is minus 1. So this is very easy. We have already considered the first element. So we can directly start our iteration from the second element. Okay, and that won't hinder us. So what I can say that if n modulo 2, that means if after dividing by 2, it gets the output as 1, that means it is an odd number, then we would move one step. Then we would start the consideration from the second index. And that is easy to handle. Now, let us try to compile and run. Okay, this is getting correct output for the sample test case. Now let us try to submit this and see. And yes, we got an AC. So if you are here till this point of the solution and you liked it, feel free to comment and like the video so that the reach of this video could be increased. Thank you and have a nice day.